if it were a 10-point problem, I'd take off 3 points for it. No, I would take off 2 points for that answer.
Newtons.
Yes. This has no units. Cosine of 28 degrees does not have units. Because it's just a ratio of sides. And so you're left with the units of newtons there. Let's figure out what B is. Now we have 3 options to find out B at this point. The simplest, in my opinion, is this one right here. So B is going to be 75 sine of 28 degrees. We could use this one up here because we know A now, so B is also equal to 66.2 tangent of 28 degrees. Or Pythagorean theorem.
I think we go with the simple solution. I got 35.2.
Thank you.
Oh, no.
But together, you fight crime. Anyone else got the same thing?
Yeah.
Okay. By the way, I said this was physics. Physics is, the fact that I threw newtons in there, and we're talking about forces, that's a physics thing. But being able to break up this is known as a vector, into components is going to be something we'll be doing throughout this semester, and for those who hang around for 152, next semester.
Are you the only physics teacher?
No, Miss Sasson also does, she's the other full-time.
Okay.
Now notice one of the things I did over here is I took, what I'll say is the first shortcut. I didn't write newtons here. I need to make sure I have the correct units in the end, but I don't have to write the units all the way as I'm keeping track of things. I did degrees just out of habit, but just so long as I know what I'm doing when I get that, and make sure I have the correct units in the end. Slightly more abstract. Now, some of your calculators will do this. You can just get in the right function mode, and you can type it out, and it'll give you the answer. But we're not going to do it that way. If you know how to do it, great. If you don't, that's fine. Well, first thing I do is notice I've got a magnitude here, and I've got a direction. I have a magnitude and a direction. Yes.
The M is for magnitude, not
No,
meters?
M is for meters.
Oh,
But the magnitude is 5 meters.
okay.
So we have a magnitude and a direction. Over here we had we had a magnitude and direction also. I just did it more visually than numerically, or I drew it out as opposed to writing it in this form. This form right here, where I give you the magnitude and direction, this is known as polar form. Now, there's not a lot in physics where you can't have to state your assumptions, but this is one of those exceptions, at least the way I do it. 0 degrees is that way from your point of view. That's 0 degrees, 90 degrees, 180 degrees, 270, and 360. I think as I wrote on the board 2 days ago. If you wish to define 0 degrees in a different direction, just make sure you state it. So first thing I want to do, and also it is possible to solve this using law of sines, law of cosines, not required for the course. So I'm going to do it the right triangle trig way. But if you know how to use law of sines, law of cosines, and want to use those, go for it. So the first thing I'm gonna do is I'm gonna draw what, I need the visualization. So 37 degrees, let's see, if that's 0, 37 is somewhere around there-ish. And this is 5 meters. And I need to figure out how much is that to the right and how much of that is up. Well, conveniently,
Did I always say 37 degrees means that the other one's 53 degrees?
yes,
And then that means these are 4 on the opposite and 3 on the or no, the other way around. 3 on the opposite, 4 on the adjacent.
yep, we got 3, 4, 5 triangle. If that bothers you that we rounded there, then feel free to write it out in much more detail. And just as a quick note, if this is 37 degrees, and when I break it up into how much to the right, how much up, these are known as perpendicular components. So I'm breaking this up into perpendicular components. Now, I could write the word perpendicular out, but as a physicist, I don't feel like writing that much. So I'll just use the shorthand symbol of perpendicular components. But for the budding English majors out there, I go through life bad-mouthing English majors, and then my daughter becomes one. But she's not borrowing money from me, so hey, all right. Now the other one, we're gonna go through that one in a slightly longer, actually, if we had to do this the shorter way, I'm gonna label that as A and that as B. I'm gonna do the next sort of shortcut here. The first way I did this is I wrote it out cosine adjacent over the hypotenuse, and then multiplied both sides by 75 newtons. In essence, it's the hypotenuse times the cosine of that angle. So A is 5 cosine of 37 degrees. B is 5 sine of 37 degrees. Or if you went to the other corner, that's also 5 sine of 53 degrees and 5 cosine of 53 degrees. And you should get something very close to 3 or 4. Or 3 and 4. Well, let's do the other one. First thing I'm gonna do is I'm gonna write it down. I'm gonna break it up into perpendicular components. And another side note, speaking of family shame, Dad was an English major too. Even wrote a grammar textbook. This is going to be the hypotenuse times the sine of 60 degrees. This is the hypotenuse times the cosine of 60 degrees. Now, 4 times the cosine of 60 degrees, I got you there. That one, 3.4 something. Someone to be kind enough. Anyone? Gilbert?
Oh, I did that one. Oh, 3.464101611514.
I got 3.46 something.
That's
There we go.
fine.
Let's not forget the units. So I have figured out I've broken up into perpendicular components. It's easy enough to add things that go in the same direction or opposite directions, but we have things in the same direction here. So this first one is 4 meters to the right and 3 meters up. That's the first one. And the second one is 2 meters to the right and 3.46 meters up. If we add these, what do we get?
Meters to the right. And 6.46 to the up.
To the up, that's one there right there, to the.
Units there. All right, so we got 6 right and 6.46 up. I will tell you, having to write out the words right and up, oh, so much writing. Is there a simpler way? Yes. Yes, there is.
Where did you get the 53?
The 53, if it's a right triangle, and because they're breaking into perpendicular components, it's a right angle there. If that's 37 and 90, that has to be 53 degrees, so they add up to 180.
Okay, thank you.
Other questions? All right, so let's save ourselves some time here. I don't feel like writing the word right. So what I'm gonna do is I'm gonna come up with some symbol to represent right. So what I'm gonna do is I'm just gonna say, I'm gonna point an arrow to the right direction and write the word, write what's called I hat.
That looks more complicated than right.
Oh, it becomes so much easier in the long run.
Okay.
And then up, I don't feel like writing that out, so I'm just gonna draw an arrow upwards and write J hat. If you don't like I and J, pick your own letters. I will stick with I and J. If you've had physics before, your other books or instructors might use X hat and Y hat. Really don't care for that. You guys, math people have brainwashed us into thinking X, Y. And sometimes that really is inconvenient. There's a video out there where I solve a problem that we'll get to later on. I solve a problem with the horizontal vertical coordinate system, and it takes about 3 times longer than solving it in a simpler coordinate system. So instead of writing all that stuff out, my problem here becomes 4 meters I hat plus 3 meters J hat. That's the first one, plus 2 meters I hat plus 3.46 meters J hat. And we end up with 6 meters I hat plus 6.46 meters J hat.
So would that be the same for left, when you go left and down? You just pick the letter and then do the hat?
If I would only need to define left or right in terms of horizontal. So if that's I hat, then what would you guess that is?
That would be,
Also,
We need to be more specific than that.
I hat left.
Negative I hat.
Yeah, there's a negative.
Okay.
So negative, in this type of notation, negative just means, oh, the opposite way.
Okay.
This is the sum of those two things. This right here is known as rectangular notation.
So you don't have to write out the arrow every time, just put the letter?
Right, once you define it for a problem, you are set for the rest of the problem. Matter of fact, on the quiz or test, if you write at the very top of the page, you can define it for the, I will call it a global notation. If you want to change it for a specific problem, you can, but. I hat, J hat, the direction that you pick. You want to pick the direction so that the math is the easiest. I could have picked I hat up at an angle like that and J hat at an angle like that, so that they're perpendicular to each other. It would have made the problem incredibly more difficult. But I can define I hat any direction I want. As far as this course is concerned, J hat is perpendicular to it. If you get far enough in physics, you get to the point where I hat, J hat, you start to deal with these things that are not necessarily perpendicular to each other, but that is well beyond the scope of this course. All right, questions here before we hit some major vocabulary words? Tristan?
So is this just like a conversion thing, like polar to rectangular notation?
What was the question? Polar rectangular?
Is it just like a conversion from polar to rectangular? Is
Yeah,
it like,
in
that's all
essence.
it is?
Yeah. Yeah, in math class, you'd be given, I guess, a point on a point in space, and if you're given the x and y values, you can convert it to polar by the distance from the origin and the angle. But we're gonna take that concept and add new vocabulary to it, just so it sounds more complicated.
Oh, yeah.
That's right.
Sounds fun.
All right, let's make it sound more complicated. Anyone in here had physics before? 1, 2, and a half, maybe? These things that we were dealing with, what are they called?
Magnitude and direction.
If something has magnitude and direction, what? I heard the magic V word over there, vector. These are vectors. A vectors are, let's see if I can use English this time. A vector, let's clear this. A vector, it's a mathematical construct. That has a magnitude or size and direction. Those are the key things there. If the direction of a quantity matters, we are probably dealing with a vector. What we have just demonstrated right here is known as vector math, vector addition more specifically. Suppose there's only a magnitude and direction doesn't matter, such as the number of people in this room. The direction doesn't matter. What are those words called?
Not vector addition.
They come up with a simpler thing than not vector.
Okay.
It's the math you've been working on since kindergarten or before. Algebra. You've been doing algebra since kindergarten? Impressive.
Okay.
Spoiler. Scalar. Can't believe your kindergarten teacher didn't talk about scalar math. They just called it math. Mathematical construct that has magnitude. Direction does not matter. I will use the term scalar and vector, but just remember that scalar is, I don't care about direction, so if I'm dealing with scalar math, 2 plus 3 equals 5. If I'm dealing with vector math and I say what's 2 plus 3, the question should be what's the direction of them, because it matters. So these are two vectors. These are also vectors. They have a magnitude, they have a direction. Specifically, they are known as unit vectors. If you see the hat over the letter, you are indicating it is a unit vector. Unit vector. The direction is the direction I say it is. Why is I hat to the right? Because I said so. Why is J hat up?
Because I said so.
That's right. Now, once I said what I hat is to the right, J hat, well, I guess it could be anywhere in this circle it so long as it's perpendicular. What is the magnitude of these vectors?
6 meters, like 4.6, or 4.46.
No, it's not the magnitude of I hat.
Oh,
We'll give you a hint, it's called a unit vector,
oh, so it's a unit.
otherwise known as 1. The magnitude of a unit vector is always 1. The direction is, for I hat, j hat, what you say it is. There are some other unit vectors, r hat, which we'll get to later, which does have a narrow definition. I've got some limitations on the direction of r hat, but that comes in chapter 6, somewhere around there.
It's not in a different place.
So let me rewrite this problem differently. I'm going to define a vector A. Now, if I wanted to make sure that you know I'm talking about a vector here, more than just writing down magnitude direction, I need to somehow, there's got to be a symbol to indicate that it is a vector quantity. So I put a little arrow over top. The arrow over top does not indicate it's going in that direction, it's just indicating A is a vector. Highly recommend you watch the videos, but I could also write it on tests or quizzes, because the word processor makes it a lot easier. It'll be the full arrow as opposed to what I refer to as the half arrow. Some textbooks, you can see why this is not convenient on the board, we'll do boldface for vectors, and then sometimes I'll do what I'll refer to as the double print. I think there's pretty much only one case where I do that for whatever childhood scars caused that, but this is the way I typically do it. So I'm going to say I have a vector of 5 meters 37 degrees. I have another vector B, which is 4 meters 60 degrees. And so A plus B equals 6 meters I hat. Plus 6.46 meters j hat. And I define I hat, j hat over there, but let's just I hat